When finding t-values using the t-distribution, we can use the tables or we can use software. The tables, however, sometimes are limited in terms of the number of degrees of freedom. I've got a piece of the t-distribution here. It includes 28, 29, 30, blah, 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 down to 60 degrees of freedom. But I don't have every single value between 28 and 60. The question here is asking us to determine what t-value would we use if we wanted to cut off tail areas of 0.05 for 39 degrees of freedom. Now 39 degrees of freedom really corresponds to a sample size of 40. Okay, but I don't go looking for my sample size. I look for degrees of freedom, which is n minus 1, one less than my number of one less than my sample size. When I look at this table gives me 35 degrees of freedom or 40. It doesn't give me 39. Your note here says you could look up a value that corresponds to 35, which is the 1.684, a value that corresponds to 40, which is 1.690, and usually, to be conservative, we go with the bigger value, which will give us wider confidence intervals and all of that sort of thing. Alright, so sometimes this is not great. We might want to have a more precise answer if our table doesn't give us the correct number of degrees of freedom. So for that, we could go to Minitab and see how this would work. Alright, I open up Minitab, and this is easy peasy. Go to the graph menu. We want to use this thing we've used before with the normal distribution, this thing called probability distribution plot, which shows us areas under the curve. Alright, we want to view probability. In other words, we want to view areas under the curve. I click OK. Window opens up. The default is that it's going to use a normal distribution, but in our case we want to use the t. So just scroll down until you find it. And the way the t-distribution works, its shape differs for every conceivable sample size or degrees of freedom, so we got to tell it. Give me the table that corresponds to 39 degrees of freedom, which, by the way, also corresponds to a sample size of 40. Okay, we click on the tab Shaded Area. We want a t-value that cuts off tail areas of 0.05. in the tail of the distribution. Alright, now I could do this two ways. First of all, probability is area. The default is 0.05. I could just leave right tail on right here and say OK. And what Minitab tells me is that when, I know it says X, but this is the t-distribution. This is just the way this thing displays. This is really t. The t-value that will cut off an upper tail area of 0.05 is 1.685. That's the critical t-value I would use. Now if I were to go back in and redo this for a minute, shaded area, if I wanted it to show both tails, which I don't have to, but if I want to do both tails, well, each tail is 0.05, so collectively they are 0.10. And if you choose both tails, it takes this probability or this area and divides it in two. So what do I get? I get, and by the way, if I really want it to be correct here, I would change this to t. Okay, so my t-value is minus 1.685 on this side. We'll cut off a tail area of 0.05, and on the upper side, a positive 1.685 cuts off a tail area of 0.05 on the upper side. Okay, so the point of all of this is that you can find these t-values using software, which is more correct than having to use the tables.